Good afternoon, and welcome to this episode of Altitude, our monthly look at the world of air traffic control and aviation. My name is Taraka, a consultant, and NATS predominantly focused on the realm of new airspace users, with the prime focus of enabling and integrating new airspace users into our airspace. Thank you all for joining us today, and I'm delighted to be in the host chair as well as being a panelist. In today's show, we're exploring the next generation of aviation and airspace users. Air taxis and mass drone operations and spaceports might sound like science fiction, but it's a future that is far closer than you might think. Within a few years, a drone could be dropping your prescriptions at your front door as you book an electric air taxi to take you to the airport, whilst a few miles down the road, a communications network company might be launching a satellite from the local spaceport. It is part of the industry that has accelerated massively over the past few years and is now on the verge of becoming a reality, with the potential to change how we travel, connect communities, and decarbonise local transport. Today, we're in urban air mobility to discuss the implications for air traffic management and unpick the technology and regulatory hurdles that still need to be overcome. I'm thrilled to be joined today by two superb guests, Elizabeth Chow, Head of UTM Strategic Development at NATS, and Richard Haupt, Senior Vehicle Architecture and Integration Engineer from Vertical Aerospace. Hi, Elizabeth and Richard. Welcome to Altitude. Don't forget, you can post your questions to our panel using the box on your screens, and we'll get to as many as we can later in the show. Before we get into things, tell me a bit about yourselves. Elizabeth, why don't you kick us off first?
All right, thanks very much, Taraka. So my name is Elizabeth Chow. I work as the head of UTM Strategic Development here in NATS. I work with a team that is all about integrating new airspace users safely into UK airspace. I'm very excited today that I'm actually speaking to two very good friends of mine, Richard and Taraka, on this topic that I'm passionate about. Prior to joining NATS 2.5 years ago, I was working in the Civil Aviation Authority Singapore, where I was also dealing with drones in the drone program office. So yeah, I think that really sums up my experience. Richard, would you like to go next?
Hi guys, yeah, thanks very much for having me, both of you. My name is Richard Haupt. I'm a Senior Architecture and Integration Engineer at Vertical. I've been with Vertical now for close on 3 years, and in my time I've worked a variety of roles there, both in the architecture team as well as the digital systems team. My focus now though is mostly on aircraft level integration, and also perhaps more relevant to today's topic, it's on outward facing systems integration topics, and understanding how the interfaces between our aircraft and the environment in which it's going to fly, in order to ensure that we're designing the right aeroplane.
Thank you very much, Richard. Looks like we've got the right people on the call here. So let's kick things right off. So urban air mobility, or UAM as we abbreviate it to. So what is UAM in basic terms? Richard, if I may come to you first, please.
Yeah, I think the genetic answer to this question is it refers to the use of air vehicles operating at lower altitudes within urban and suburban areas. It's nothing new, to be fair. This sort of goes back to the 50s and 60s, when a few UAM networks emerged mostly in the United States, using helicopters. Turned out that wasn't really a sustainable solution for a number of reasons. So hence why we don't really see it anymore. But today, when we talk about UAM, it's more in the context of using newer, greener, typically electric air vehicles. Many of them have got a vertical takeoff and landing capability, as the VX4 does, and they provide mostly passenger carrying flights within and between built-up urban cities. So if I paint a picture for you, imagine you need to get from one end of London to the other. You'll board a vehicle at a vertiport, or maybe at an existing heliport and airport, all of which are designed and have the equipment required to service these vehicles. The service you use could be pooled or it could be personal. Pooled meaning you're with people that you don't know. Personal being more like a traditional London cab. It could be a scheduled service, or it could be an on-demand service. You'll climb in, you'll get airborne, and you'll join a network of other UAM vehicles that are all coordinated, all flying in the same airspace. And you'll fly directly to your destination on the other side of London, in a fraction of the time that it would have taken using ground infrastructure, and maybe more importantly, in a very predictable amount of time. As you know, ground infrastructure can vary. And then if that vehicle is an eVTOL or electric vertical takeoff and landing aircraft, then it's also going to be a carbon-free ride.
Thank you, Richard. That sounds really interesting. I mean, it's effectively connecting up cities, right? Providing connectivity between regional areas, like you said, in areas where normal modes of transport might take longer to service particular users.
Yeah, exactly.
Yeah. Okay, so why do we want UAM to become a reality? Like, why is it so important for us? Elizabeth, if I may come to you on this one.
All right, thank you very much, T. Anyway, Richard, that was a really good analogy, so thank you for that. I really can see the picture in my head. Why UAM is why do we want UAM to be a reality? So this really stems down to market demand and market supply challenge issue. So in the last 2 years, where obviously all of us in aviation would know that the traditional aviation has had unprecedented low demand. The reverse is true for the new airspace users. In fact, 2.3 billion US dollars was invested in the drone industry in 2020, in year 2020. And of that, over 90% was invested in the manufacturing of advanced air mobility aircraft, of which vertical aerospace that we have on this call, thank you, Richard, is one of them. So this is really huge number that portrays the that the reality is here that people are putting a lot of investments into this industry, and NATS has been safely managing millions of aircraft every year. We are focused on safely integrating all types of airspace users without disrupting those that are already in the air, and so this is really critical for NATS to safely integrate the likes of AM vehicles such as vertical aerospace into UK airspace safely and efficiently. And on that point, though, there will be plenty of challenges. And what it really means to ATC is that we would require, what it means to air traffic control is that it will require a new way of managing the airspace. New airspace users will have more, will have different flight parameters and will have more demands on autonomy, etc. And that would also require parallel developments in air traffic management. And this is not unfamiliar territory for NATS. NATS has been always open to innovation. In fact, for our existing air traffic management systems, there has been waves of innovation simply to adapt to the ongoing needs of the airspace users, whether it is virtualization of data or placing data in the cloud system. So yeah, I hope that's all right as an answer. It got a bit long, but yeah, no, that's the reason why it is a reality.
Yeah, no, of course. And if I may add to that, Elizabeth, as well, I think today, in terms of air traffic control, NATS manages controlled airspace in a sort of segregated way. And as these new airspace users arrive and want to operate in the same bit of airspace effectively, we need to move to a more unsegregated, integrated traffic management approach, which is why we're involved in such projects and involved in pushing on this new realm of urban air mobility. Yeah, interesting stuff. So in terms of like what needs to happen next to get it off the ground commercially, Elizabeth, do you want to take that one?
I'm okay taking that on first, unless Richard wants to take that up first. All right, then I'll go first then. There are plenty of challenges to get urban air mobility off the ground, so to speak, to get into airspace. Oh, puns. So in fact, the lessons that are around the challenges actually came up from preceding work that we've done with Vertical, and that is the CAA regulatory sandbox, with the UK CAA regulatory sandbox work to look at how do we have urban air urban air mobility in London, and we have had 2 airports involved in that project, Heathrow Airport and London City Airport. An outcome from that project is really the publication of CAP 2272, just to get my numbers correct, CAP 2272 on key considerations for integrating urban air mobility into the UK airspace. And there are plenty of challenges in there. We can always provide the link to our audience after this, and I'll just summarize it. There will be airspace integration challenges. It's not unsurmountable, but there are challenges because we need to make sure that advanced air mobility vehicles, when they want to traverse low-level airspace, it doesn't disrupt existing users of the same airspace in that unsegregated airspace. So that's one. The second thing would be public perception, which I would call upon Richard, if that's all right, to give us more details on. I mean, we were just impressed by the stand at Farnborough Air Show just a few weeks ago, having a full-scale prototype at Air Show and allowing people to actually see it's there and believing it and engaging them on that topic is definitely an important part of that journey to get public acceptance to this new type of vehicle. Yeah. There are also other challenges with regards to making it off the ground, and that's like investment in that infrastructure, in the air traffic management system, which I would just speak later on. Yeah. Richard, do you want to add on to this?
Yeah, I think there's a couple of other points I can mention. I think T, you asked the question specifically about getting this off the ground, so to speak, commercially. I always think when you have a commercial service, it's about supply and demand, right? So the obvious point here is, as of what needs to happen next, is that we need vehicles. As an OEM, that's our job. We're coming along to the party with the VX4. That's going to be an incredibly safe and efficient aircraft. It's going to be certified to the highest standards. But in addition to vehicles, we also need operators and other ecosystem stakeholders to provide these services and solutions to enable these UAM networks to happen. I know there's just the 2 of us on the call today, but there's so many other participants in this ecosystem. We could talk about ground infrastructure, be that a new vertiport, this term that's come up, or existing airports and heliports that are being modified to accept these aeroplanes. And that ground infrastructure has got many elements to it. There's the passenger terminal facilities, there's the booking services that sit behind that, the services that the operators offer, they're the airside ground services, part of that infrastructure. I'm talking about things like charging systems. And then once we get airborne, you guys have covered this already, there's a lot of the airspace integration challenges. And there's many ways we can integrate into the airspace, and each of those ways has different challenges. So that's just some of the supply side. And there's the demand side. And this is, Elizabeth, you talked about public perception and public acceptance. For us, it's not just about the public accepting our product. We want the public to embrace eVTOLs and the services that are going to be provided with them. So yeah, a lot of work on our side and on our partner side to ensure that the public know that it's going to be a service that's safe, it's going to be a service that's environmentally friendly, and a service that's affordable. And we saw a lot of that starting to happen at Farnborough, as you said, Elizabeth. Then there's, again, on the demand side, there's a lot of work to be done understanding when networks are to be launched, and in each network, which routes are going to be best. That's something we're working with our operator customers on. And I think one of the bigger points is that ensuring the aircraft and the ecosystem services that are being, we're all developing these things in isolation, but ensuring that they're all matched to the customer's requirements. I mean, that we've got these things happening at the right price, the right reliability, the right level of safety, in such a way that it's providing a beneficial service. So understanding these requirements now is really crucial, not just for the aircraft development, but for the development of all of these ecosystem services.
Yeah, thank you very much, Richard. I think most of what you said as well are sort of hurdles that need to be overcome as well, isn't it? Like such as social acceptance, public perceptions side of things as well. Is there anything more you'd like to say on that in terms of the hurdles that we need to overcome?
Yeah, it's, I always tell people that we're not designing an existing airplane to fit into existing airports and existing airspaces. Everything seems to be new, right? So there's so many hurdles. From an OEM perspective, from a vehicle manufacturer point of view, designing airplanes with electric powertrains, it's not easy. It's no surprise that it hasn't really been done before. Batteries and electric powertrains, clearly, that's very new. So the stuff we're designing is on the edge of what's physically possible. So that's a huge challenge for us day to day. But it's not just about designing the aircraft; it's designing it in a certifiable way, and then taking that aircraft through the certification journey. The certification journey being sort of the difference between designing it, saying it's certified, and actually proving that it is certified, proving that it is safe. And yeah, the standards, those certification standards that we're certifying to, they're also very new. So we've been working closely with the regulators to ensure that the standards that we are using are what we believe to be the most stringent safety standards out there. It's the same sort of level of safety that commercial airlines currently use. Yeah, and I spoke about talking about hurdles, but I spoke about some of the other services that need to be developed in my last answer, so I won't go over those again. But I think it'd be a shame if we showed up in 2025 with a certified airplane that's ready to go, ready to be launched, but at the same time we hadn't all those other services hadn't been developed to be ready at the same time, or they didn't connect properly. That'd be a real shame. So I think there's another hurdle in that we ensure that all of these solutions aren't designed in silos, that we're all working together.
Yeah, I think that's the most important part of industries like this, about collaboratively within the industry coming together, trying to make this ecosystem work as a whole by a specific date, so that everyone can go into commercial operations without a piece of the jigsaw missing. I think that's one of the key points here. So in terms of we outlined the hurdles there. What are NATS and Vertical doing to prepare for that? Elizabeth, if I may.
So just really excited to mention the Future Flight Challenge 3 project that we are both involved in, and Tharaka, because you've led the bidding on NATS side. On NATS side. For that, I'll leave you to speak about about that project. And besides Future Flight 3, we were also involved in Future Flight 2. And beyond that, we are also involved in more regulatory issues. So beyond just project-based, I think both parties are also very piped into the regulatory efforts to engage more of the industry, to build that strong ecosystem that Richard mentioned earlier, that you actually need a lot of people within the ecosystem to play their part. So recently there was a group called the Future Aviation Industry Working Group Airspace Integration, which both parties are contributing towards. We're not the only contributors, there's a lot of other contributors, but these are all regulatory engagements that we are active in. Yeah.
Thank you very much, Elizabeth. Richard, is there anything you'd like to add before I move on to Future Flight Challenge, as Elizabeth mentioned?
Well, I suppose all I can say is that between us and NATS, the sort of the method that we're using to try and surmount to try and get through these challenges is to, we're providing the context of what these networks are going to look like, and sort of asking you what currently doesn't work to support these networks, and also understanding what the current limits of the existing services are, so that we can identify what the correct services are and steps are to getting to the place that we want to be.
Yeah, no, completely agree. So Richard, one last question for you before I jump onto Future Flight. When do you think people will be able to routinely jump in an air taxi to go on a journey?
Our timeline is to target full certification by 2025. And then shortly after that, we're going to begin delivering vehicles to our customers. Some of them you may have already seen. American Airlines are a big customer, Virgin Atlantic. So yeah, shortly after 2025, they're going to start operating.
Thank you very much for that. So hopefully in the next 3 to 4 years, I'd say. Okay, so moving on to the Future Flight Challenge. So a bit of context mainly for the audience. So the Future Flight Challenge is a government-funded initiative sponsored by UKRI and the government to accelerate the UK PLC to advance aviation in the country. The Future Flight Challenge is mainly looking at four distinct areas: new models of airspace management and legislation, novel air vehicles, infrastructure, and also operating models. The Future Flight Challenge consisted of 3 phases, of which phase 1 completed a few years back, and phase 2 projects are slowly closing down at the moment. And phase 3 projects are just starting up now as well, which run for another further 2 years. Phase 2 is mainly about developing concepts and the trials and understanding the problems and jobs to be done to enable this industry. And phase 3, which we are embarking on now, is more about applying these concepts, making them real, and demonstrating the end-to-end viability at a larger scale to enable the industry to move forward into live operations post Future Flight phase 3. It's actually quite amazing to think of how much investment has gone into the world of UAM and into the Future Flight Challenge by UKRI in providing the opportunity and supporting organisations to help accelerate and enable the future of aviation in the UK. So my personal thanks to everyone that's involved there as well. As the NATS project manager for Future Flight phase 2 and the solution lead for our involvement in phase 3 to date, I can say it's been a great journey so far, collaborating with industry partners on such innovative and groundbreaking projects. Aviation in the Southwest, which is the name of the project that we were involved in phase 2, is a project collaborating with Vertical Aerospace and many others, focusing on integrating eVTOL operations into an urban environment in the southwest of the UK. Richard, if I may come to you first, would you like to elaborate on the phase 2 project and the outcomes as it just finished a couple of weeks ago, at the end of last month?
Yeah, that's right. Yeah, I don't mind doing that. So it's been a year and a half, I think, phase 2. As you said, the project that we were part of, the Aviation Innovation in Southwest, was one of many phase 2 projects, right? So yeah, we started the beginning of last year and it ended midway through this year. And over that year and a half period of time, I think some of the topics we covered were demand modeling, social acceptance. We spoke about that earlier on the public perception point. There's been a lot of work on vertiport development and integration of vehicles into vertiports. There's been a lot on airspace integration. Obviously, that's where you guys have helped quite a lot. And then the development of digital air traffic services. So there's been a number of players in the phase 2 project who've been working towards these digital air traffic services. And what we recently did in the last month of the project, we did a demonstration, a live demonstration in a real world air traffic situation. The vertical flight simulator was connected up to the real world air traffic picture, and we flew a mission that involved some deconflictions. Deconflictions are effectively instances where aeroplanes flying on the same path, and there could be a midair, and a system comes along and solves the problem, tells one aeroplane to perform a maneuver to avoid conflict, or it changes the flight plan in some way. So we demonstrated that was really successful. I think one of the points to note is that the demonstrations we did, there was a lot of simulator-based demonstrations, and a lot of them were isolated, so they weren't full end-to-end tests. If we wanted to test a full system, we test individual chunks of it and just show that they all worked, to sort of prove that the bigger system worked. So when we go over to phase 3, that's going to be one of the things that's different. There's going to be a lot more real-world flying, and there's going to be a full end-to-end demo, and that's going to be everything from passenger booking right the way through to passenger check-in, and demonstrating all of the physical and digital services both on the ground and in the air work and integrate with each other, and then passengers get off at the other end. So yeah, it's going to be a step up in terms of demonstration.
Yeah, no, that's really interesting. And personally, for me as project manager on the NATS side for aviation in the Southwest, I think one of the main key points that and outcomes from the project is the collaboration aspect. A lot of industry partners came together with their wealth of expertise working together to try and make this a reality in the future. And I think that's something really important. I think a lot of people have worked together quite well in making that happen. So and that's led to further sort of exploitation opportunities outside of future flight and around the world as well. So yeah, great opportunity there. So yeah, as you mentioned, the project has been successful post phase 2 now and going into future flight phase 3 under a new name, Air Mobility Ecosystem Consortium, or shortened for AMEC, as we shorten everything in this industry. So we're working with a whole range of partners, most of them which have come through from phase 2, such as sort of Atkins, who are the consortium leads, Connected Places Catapult, Skyports, Virgin Atlantic, Bristol, London City, Heathrow Airport, Cranfield University, University of Warwick, and of course not forgetting ourselves, Vertical Aerospace and NATS as well, and a few other grant fund and non-grant fund partners as well. So yeah, again, like you said, it's a really good collaboration, and hopefully we will see the VX4 flying towards the end of the project in a real life demonstration. So yeah, great stuff. So, Richard, you basically touched on, I think, what the AMEC project is trying to achieve. Elizabeth, I don't know if is there anything would you want to add to that as well, in terms of how we're going to try and achieve those objectives together as a consortium?
Okay, thanks, T. And I love the description that you guys have built out what we've done in Future Flight 2 and about how the successes that we're building towards Future Flight 3. And this is what is happening in the industry, right? You learn what you've gotten from one phase, and then you try to continually improve. It's part of the safety culture that we're building in this industry as well. So in Future Flight Phase 3, NATS is the airspace management lead, so the work package lead. Okay, without getting too much into specifics, really what NATS wants to do is to identify the different airspace requirements that are best suited for this new airspace user, so AAM, Advanced Air Mobility, and then to further create the necessary assurances for a successful operational trial by the end of the 2-year Future Flight Phase 3 project. NATS will be putting in a lot of resources into making sure that the assurances are rigorous. They are put in place for further exploitation later on. We are involving the likes of our analysts, our air traffic controllers, policymakers within NATS to make sure that this project is sound. Yeah.
Thank you very much. Richard, anything you'd like to add?
I think Elizabeth captured it all there.
Thanks. For the first time.
So in terms of like the work completed in this project, or going to be completed in this project, how will that help UAM to become a reality? So I mean, from a personal perspective, I know a lot of the work that's going on with all of the different consortium partners, not just in the AMEC project, but in all of the future flight projects as a whole. They're going to be informing government, informing regulators to try and influence the best way forward in making this a reality in the future. Other than that, is there anything more that either of you would like to add to that in how this would be become a reality?
Yeah, I think that one of the things we've seen in phase 2, and I think we'll see it again in phase 3, is that it's allowed a lot of iterative testing. And when you iterate on solutions, you really iron out which ones work and which ones don't work. It's really important that when we put solutions out there, we've effectively asked what is the problem that we're trying to solve. So we're not brute forcing a solution to fit a problem that doesn't exist. That's been really useful in phase 2, and you know, the sort of the sprint way of working that we've done in these consortiums ensures that we're regularly testing and asking ourselves that question. And then I mentioned earlier that end-to-end testing, you really can't kid yourself when you're doing end-to-end testing. If it doesn't work, you don't have a product, you haven't demonstrated it. So yeah, that's the difference between the isolated testing and that end-to-end testing. So I think coming out of Future Flight Phase 3, to make it out and have done those demonstrations, we will have had to solve all of the challenges.
Yeah, I'm just gonna build upon that as well, if that's all right. It's also the setup of the UKRI and the CAA involvement within this Future Flight Phase 3 project, and that's slightly different compared to the previous ones. The CAA would be putting their resource within the Future Flight Phase 3 project, so one personnel from the team, from the CAA team, would be involved in the project. So we're really excited to work closer with the CAA to make that the solution that comes out of the project practical and scalable. Yeah.
Yeah, thank you, Elizabeth. And I think that's just a realization now from everyone in the UK that this is actually coming. Hence why everyone's sort of getting involved more and more as we move forward. So yeah, really exciting stuff. And to think that the AMEC project is just one out of many projects that were successful in phase 3, not to mention all of the other projects that were funded in phase 2 as well. So congratulations to everyone involved in the Future Flight Challenge. Yeah, let's make this a reality in the next few years. We actually have some questions coming in from the audience now. So first question is from Anders. Will urban air mobility be managed by ATM like NATS? If not, what will the interface look like? Elizabeth, if I may come to you on this one, if that's okay.
Yeah, definitely. So urban air mobility or advanced air mobility, however the term is, it will require an airspace manager, whether it is NATS or another ANS service air navigation. I have to avoid acronyms, so or another air navigation service provider. There needs to be an airspace manager. Let me give an example. If it is an existing airport that is managed by NATS, then I'll be expecting that airspace management responsibility will lie with the air navigation service provider. So in that case, it will be NATS. However, as we're really and fully embracing the new world where there are other types of ground infrastructure, whether you're talking about vertiports, I think vertiports was introduced as a term early on, then there will be other service providers, but the need for airspace management doesn't change. You still need an airspace manager there. And even at the vertiport itself, they will need a form of air traffic service. Yeah.
Thank you very much. Second question has come in from Kel. My concerns are around the progress in conspicuity and integration. I think those challenges are significant. Above all, I'm not hearing much about the impact of noise. Is this perceived as a major blocker to progress? Richard, if I may come to you on that in terms of a vehicle OEM perspective, please.
Yeah, I can talk about noise. Maybe conspicuity. I presume that's EC, electronic conspicuity. Yeah. That I'll maybe leave that for Elizabeth. But yeah, noise is a massive consideration for us. We're designing to be a lot quieter than a helicopter, both inside the vehicle and outside the vehicle. We're, as part of all of our public perception work and a lot of all of our application processes that we're going to go through to operate in these new networks, there's going to be public consultation. So we're doing everything we can to understand what the requirements are on noise and making sure that we meet them. That's both external noise for the networks that we fly in, and then we also have to understand what our customers are likely to be able to tolerate for the services that we're going to, what they're going to tolerate in the aeroplane for the services that we're going to offer. So yeah, noise drives a lot of aircraft requirements from our point of view.
Yeah, thank you. Elizabeth, do you want to touch on the EC point?
Yeah, thanks, Cal, for that question. Really, it is a tough question to answer. I fully agree with the concerns around conspicuity or integration, because probably I've said it more than once now. I'll still say it anyway. So NATS is really focused on integrating all types of airspace users without disrupting existing ones. So part of that would be asking or requesting the new airspace users to be electronic conspicuous, so that aircraft using, say, uncontrolled airspace will be able to detect those new airspace users around them and take the necessary measures to avoid. So that's one point that I want to raise. The other point about noise is a lot of the discussion about noise will also surface when it comes to social acceptance. And as you know, a lot of things in aviation go through rigorous rounds of consultation, public consultation, and there will be public consultation on these issues, whether it is through in the far future on airspace changes that are required, or around the policies. And I would like to just, I probably have to touch on this point as well. There are regulatory engagements to get that going with a lot of flying communities, whether it is general aviation, etc., or drone users. In fact, NATS has been leading a Beyond Visual Line of Sight Operators Forum to get as much opinion out of the people operating those drones. And similarly, we are also interested to hear from advanced air mobilities operators and manufacturers on what do you think your problems and challenges would be, and how can NATS really help with that. Yeah.
Thank you, Elizabeth. Another question that was coming from Andrew. Is current UTM thinking that there will be any distinction between the treatment of integration of UAVs carrying passengers versus ones that are not?
I'm happy to take that first, unless you are ready to go.
Yeah, go for it, Elizabeth.
A lot of people there's a misconception that's quite common for advanced air mobility. At the entry into service stage, when it first starts, it will be piloted. So a lot of people have that misconception that I just want to address, that when we talk about advanced air mobility, the very first phase, these are piloted advanced air mobility vehicles. That said, in our UTM thinking, there is a distinction between, in our thinking, there is a distinction between passenger carrying AAM and cargo carrying AAM. Simply because there's a safety management framework that has been rigorously applied to the crewed aviation world, and that will also be extended to the uncrewed aviation world. And when you carry passengers, there will be additional safety management requirements. On the other hand, and I'm complicating things now, on the other hand, the communications, the way of communicating with the pilot on board the aircraft or the remote pilot can actually be quite similar. We would be moving towards digitalized form of communication, very much so similar to what we're doing with crewed aviation, whether it is transitioning from voice communication to digitalized form of communication. So I hope I answered the question fully.
I think you're correct, Elizabeth. I think even in terms of treating the evolution of aircraft going forwards, in terms of going from a piloted aircraft to a autonomous aircraft in the future, I think EC legislation needs to support that, because once you sort of go to autonomous, you're effectively, I don't know, to say in sort of simple terms, I think you're effectively driving at night without your headlights on, right? So you can't see who else is around you. So I think, but at the moment, such as the aircraft that Vertical Aerospace are creating, are manufacturing, there will be a pilot on board. So hopefully, that would all go according to plan in the early, next few years. So yeah, interesting. Richard, I think this one's for you. A question's coming from Anish, saying, will an air taxi ride be affordable for the average UK citizen?
Yeah, and there's so much we can talk about on this point. Yes, absolutely. This doesn't work if it's not affordable for everybody. So it's not going to be for the rich and famous only. It's going to be for everybody. There's a lot of challenges for us to achieve that. You know, we've talked about airspace integration and all of these ecosystem stakeholders quite a lot. Very efficient services are going to drive that. If we can amortize the costs over more flight hours and ensure that we're operating a very efficient network, getting a lot of airplanes in the sky and having quick turnarounds, then absolutely we're going to be seeing the cost of this operation being comparable to existing modes of transport. And given the cost of time saving, that's really going to make this an attractive option.
Thank you very much. Keith asked the questions, what global efforts are NATS looking at to make sure that ATM / UAM operations are to an extent harmonious, as much as this might be a domestic effort? Global influence and synergy is also key.
Keith asked a really good question, and because it said NATS, I assume I'll be the one taking it, if that's all right.
Yeah, go for it.
Okay.
So I can chip in afterwards. Yeah.
Thank you. So NATS is part of CANSO, so the Civil Air Navigation Service Organization. I hope I got that right. So used to acronyms by now. So we have been heavily contributing to a lot of CANSO's effort to look into this issue of airspace integration. That's one. NATS is also contributing towards ICAO efforts towards this. In fact, there is an ICAO's assembly coming up just around the corner in later part of this year. So that's something that NATS is preparing to contribute to, of course, through UKCA and DFT. Something that is shown from this collaboration between this altitude episode between Vertical and us and NATS is there's a lot of, aviation is an international industry, right? And Vertical probably would not just want to operate in UK market. It is an airline, hopefully, that will also operate in non-domestic markets. And so by talking to manufacturers like Vertical, we get a better sense of your needs and what NATS as an air navigation service provider who is prepared to modernize our air traffic management system would do. And we will reflect that needs into what we can do in terms of services, in terms of our people, and that is also filtered through our political influence efforts.
Yeah,
that was kind of a tough question to answer, Keith. So thank you for that.
So Thomas has asked a question: which countries will be the first movers? Richard, if I could direct that one.
I've taken two questions, so it's your turn now, Richard.
So, who was that question from? Thomas.
Thomas, which countries will be the first movers?
Hi, Thomas. Yeah, if you have a look on our website, you'll see we've got a number of pre-order sales already, just over 1,400, I think. Although that changes quite regularly as we keep selling more. Those customers we have, they are all over the world. So I don't think I can say at the moment where our enter into service will be, but we're certainly going to be operating this vehicle all over the world. And all our intentions for the way we design the vehicle and the way we work with these partners to develop these ecosystem solutions, it's in our best interest if they are scalable all over the world. So yeah, we do keep an eye on anything we're solving in one region. We do keep an eye on how does it scale internationally.
Yeah, at the end of the day, our solutions that we create need to be scalable, right? To be used wherever in the world. So I think that's really important. Arnold's asked questions. Won't any automated ATC system capable of handling traffic below 400 feet easily be able to handle traffic up to flight level 660?
So it is an ATC related question, so I'll gladly take it. Automation in aviation, it is an ongoing trend. It didn't just start with new airspace users. I think I mentioned this earlier, where the existing air traffic management system is also undergoing in phases modernization, whether it is virtualization of data or cloud computing. So I always so you started this, Richard. You gave an analogy, right? So I'll also give an analogy as well. Think of autonomous vehicles, which vehicles on the road, which are a reality right now. I personally don't expect within day 2 for all vehicles to be replaced by autonomous vehicles. But that autonomy is built in phases. Take, for example, the lane control function or the cruise control function, which is an autonomous function, right? You don't need the driver to intervene. So on that point, autonomy is the direction of travel, but we do need to carefully plan it to make sure that safe and efficient integration of new airspace users does not disrupt existing users. And also it is, as Keith's earlier question was on harmonization, and to make sure that the pace of innovation is also in line with harmonization with international standards or countries that our partners would like to operate in.
Thank you very much, Elizabeth. Last question from Robert. Is the film Back to the Future going to become a reality? And I must confess, before passing this on to anyone, I've not even seen the film. Seen the film. So,
that's a
Can I
travesty.
add in my
You haven't seen
confession
it.
too? I only remember the crazy scientist, so I can't be much help.
Well, as much as I'm a massive DeLorean fan, I think until flux capacitor technology, until that improves, I'm not sure about time travel.
Thank you very much. So one last question from me, actually, before we close off. If an eVTOL air vehicle was available tomorrow, would you both use that as a mode of transport? Richard, over to you first. Yeah,
absolutely.
Good. I guess I would third that then and say yes as well. So yeah, well, I'm afraid that's all we have time for today. My thanks to both Elizabeth and Richard for joining me today and participating, and for everyone watching at home as well and posing some really excellent questions. As ever, if you have any feedback for us or ideas for future topics that you'd like us to cover, you can email us at info@nats.co.uk or tweet us at nats, and keep an eye on our social media channels for details of the next show. Thank you very much and goodbye.